Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good morning.
Listen,
Good morning, sir.
people of what we have done in the previous class. For uniform acceleration, displacement time graph was this. This was uniform acceleration. Uniform deceleration. Uniform deceleration. We have done uniform deceleration as well, right? This
Yes,
is
sir.
displacement time graph. Uniform acceleration velocity time graph. Velocity time graph. Initial velocity is 0 here. If not, it will come from here. Velocity time graph for uniform deceleration. Right? Here, slope will give me acceleration. Area under the curve will give me displacement. Same applies to this. Do we people remember this?
Yes.
Yes, sir.
Yes, sir.
We solved one problem in which you're projecting a body in the upward direction, it comes back to the point of projection. Have we done that?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now I'll give you one problem. This is velocity time graph. This is for 2 seconds. Time is given in seconds. This is given for 6 seconds. Right? This is given for 8 seconds, 10 seconds, and 12 seconds. Velocity is 10 meter per second. This is minus 10 meter per second. First question they asked is find average velocity in time t equal to 0 to t equal to 12 seconds. Right? Second question, find average speed in time t equal to 0 to time t equal to 12 seconds. Draw a t graph for this. Whole of the graph. Will you try?
Yes, sir.
Yes, sir.
Yes, sir. Sir, should we send the answers to you on the chat, like for the first two questions?
Don't. The problem is quite easy. Don't send the answers.
Sir, when we will have assignment 3 discussion?
Assignment
3, sir, projectile motion.
So Saturday doubt class or today in the end?
Sir, assignment 3 of projectile motion.
this is flagship batch, right?
Yes, sir.
Yes, sir.
Conclusions लिख के भेजा ना यार मैंने.
हाँ सर.
Sir, but there are still
Sir,
a
sir,
few
there are
doubts
some doubts.
in one or two questions. Sir.
Then in the doubt lecture we'll finish it off. That will not be long.
Okay, sir.
Saturday doubt lecture.
yes.
Okay, sir. Okay, sir.
Sir, in Saturday doubt lecture you can take tests, doubts also.
Yeah. Average velocity will be total displacement by total time.
Yes, sir.
Yes.
If I call this to be area A1, I'll call this to be area A2, A3. Do people know how to find out the area, right?
Yes, sir.
Somebody who
Yes,
does not
sir.
know how to
Yes, sir.
find the area of a triangle, please raise your hand. I'll get it chopped off. A4 and A5. Now,
we can directly take the trapezium's area, right?
Yes,
you
sir.
can use comfortably, absolutely no issue.
Yes.
Directly use trapezium's area. Now, average velocity will be A1 plus A2 plus A3
Minus A4.
Minus A2 minus
A5.
minus A5. Displacement के लिए subtract the area underneath x-axis divided by total time. While average speed will be A1 plus C2 plus C3 plus C4 plus C5
Yes.
divided by
Divided by 12.
the basic difference they want to see is, do you know how to calculate the displacement and distance? If it is displacement, area above the x-axis minus area below the x-axis. If it is distance, it is sum of all the areas. Answers should not be difficult for you, just calculate the
Sir,
area.
we can also see that A3 and A4 are equal and A1 and A5 are equal, so we can cancel them out directly.
Okay, but suppose they give you different values again, write the general. Acceleration time graph. I am drawing underneath. Slope of this line is the acceleration. Slope
Yes,
of BT graph is the acceleration. 10 divided by 2 is plus 5.
Yes, sir.
Acceleration time graph. Agreed?
Yes, sir.
Yes.
Here slope is 0.
Zero acceleration.
0.
2
Yes, sir.
and 6. Here slope is negative.
Yes.
And negative, what is the slope? This is 10, this is 2. That means 5.
Minus 5.
Slope is negative. With the same
Minus 5.
slope, it will
Same.
continue till here.
Yes.
Slope is positive. Plus 5 meter per second square.
Yes, sir.
Meter per second square.
Yes.
See if all of you are convinced with the graph. This is positive slope. This whole line is negative slope. Negative slope, what is the slope of this line? 10 divided by 2, that's 5. So minus 5 is the negative slope. This is the AT graph.
So completed.
Wait, sir.
So, I have a doubt.
Hello?
So, in the acceleration time graph, when you said that, so what will be the acceleration of the second? So, time equal to 2, what will be the acceleration then?
At this point, it will be discontinuous.
Okay.
There is a sudden change in velocity.
Okay, so thank you.
Sir, so we will put a circle over there, right?
I need to keep that dotted.
So wherever there are sudden changes, we just leave that space dotted, right?
There is nothing that you will do other than what I have drawn in the graph. Don't lead into new arguments. The way I have drawn the graph, do it that way. Now you want to leave some space, means you leave something here, doesn't make sense.
Yes, sir.
So
Fine, sir.
Now for the following problem, you will draw the VT, AT and ST graphs. This is a tower of height 19.6 meters. You will take this to be the origin. A body is dropped. A body is dropped from this height. Right? It strikes the ground and rises back and comes back to the same height. What is the problem? Body is dropped from certain height. It falls on the ground and it rises back to the same height. Right? We take everything in the upward direction as positive, downward direction is negative. Draw the VT, AT, ST graphs. First of all, draw the AT graph. AT graph. Then draw the VT graph. Then draw the ST graph. Displacement time graph.
So we are considering the point from which it is dropped as origin, no?
Right? Because why don't change the origin? Point from where you are dropping, that is the origin. VT, AT, ST graphs. First, calculate the time it takes to reach the ground. Calculate the velocity with which it strikes the ground. Then go for the graphs. Calculate the time it takes to.
Sir, we'll have to take in consideration the sign convention, right?
Take into consideration.
The sign convention.
क्या convention?
The
Sir,
sign
the sign
convention.
convention.
Sign
Why
convention.
did I write that there?
Okay.
Because you should take. You are verifying if I am alert.
So when it rises back, do we consider the velocity to be same as what it was when it fell, or do we consider it to be zero only?
Here,
Yes, sir.
obviously it will rise with the same speed, only then it will go back to the same height. It is falling with the velocity. If it doesn't rise with the same speed, it will not go back to the height. And in the question it is given that it comes back to the same height.
Okay.
With what velocity will it be striking here? V square
19.6 meters.
0.6 meter per second.
19.6. Yes, sir.
19.6
2
meters.
into 9.8 into displacement is 19.6. This is 19.6 whole square. Velocity with which it will strike is 19.6 meters per second. It will rise up with 19.6 meters per second as well, so that it
Yes,
reaches
sir.
the height. Second, V
Yes, sir.
equal to U plus T. Now initial velocity is 0. V is 19.6. 9.8 into T. Why are you not taking negative sign here? 19.6 is also negative. G is also negative. T is 2 seconds. So it will come till here in 2 seconds. It will rise back till here in 4 seconds.
Yes, sir.
Guys, I should be drawing the graph for first 4 seconds of the journey. This is 4. This is 2. Acceleration time graph for me will be this.
Yes, sir.
Constant.
Meter per second square
Sir.
minus 9.8. Whether the body is going up or coming down, G is always in the downward direction.
Yes, sir.
It will always be minus 9.8 meter per second square. That is the easiest.
Yes.
Velocity in the first 2 seconds is decreasing. Increasing, sorry. From 0, it's increasing to 19.6.
Yes, sir.
Yes, sir.
Yes, sir.
But
Yes,
positive
sir.
or negative?
Negative.
Negative.
Minus 19.6 meters per second. First 2 seconds, negative velocity is increasing because velocity is in the downward direction and speed is increasing to 19.6. The moment it collides with the ground, speed became plus 90, velocity became
Yes,
plus
sir.
19.
Plus 19.
But decreasing.
Decrease.
19.6
नीचे तक आएगा
Decreasing till
हाँ
4
सर
seconds.
Yes, sir.
वैसा ही हुआ
This is 19.6 meters per second. The moment it collides, velocity became plus 19.6. From plus 19.6, it is coming down to 0. All throughout the next 2 seconds, velocity is positive, but its value is decreasing. all throughout the next 2 seconds velocity is positive, so it will be above the x-axis, but its value is decreasing to 0 at 4 seconds. Interestingly, slope of this line negative, slope of this line negative, but this velocity is negative, this velocity is positive because it is in upward direction. This slope is also negative, this slope is also negative, which I am able to see. This velocity is negative, this velocity is positive. First 2 seconds velocity is negative, next 2 seconds velocity is positive.
Sir,
Hmm.
sir, at 2, the graph is discontinuous, right?
Yeah.
Sir, so then we can't differentiate a velocity at 2 seconds, but we
Yes,
have
sir,
a
I also had that same doubt.
constant slope at.
Will be taught in impulses. This is an impulsive force. Acceleration is abnormally high, rather infinity.
Okay, sir.
Right? Will be taught at impulses. Till then, go with this. Because from here till here, when it is coming, it is only under the force of gravity.
Yes, sir.
Now, when it is colliding along with gravity, there is a
It has normal force.
normal force acting on it.
Yes, sir.
Right? So acceleration is not 9.8 at the time of collision. At the time of collision, acceleration is really huge.
Sir, that is because we have complete change of velocity to 19.6 again, right?
Right.
Okay, sir.
So that way, very orthodoxly, there should be a small discontinuity here. But in kinematics, we will not be addressing it. In Newton's laws, we will address.
Okay, sir.
So we can say that we just increase the velocity from say minus 19. So we increase the velocity with the magnitude of 39.2 in no time. That is why that's discontinuity can be
Right.
seen.
Right. In infinitesimally short time. And
Yes,
at that instant, acceleration will be considered to be abnormally high. Those forces are called impulsive forces. We'll address them in detail in conservation of moment. Now, displacement time graph will be a parabola.
Yes,
because
sir.
it is
Yes, sir.
acceleration.
Yes, sir.
Now, first of all, if this is the origin, displacement all throughout the journey is negative.
Negative.
Displacement all throughout the journey is negative for all 4 seconds. Whether it is going down or coming up from origin, you have to go down. So displacement curve will be below the x-axis. First half of the journey, slope is increasing. First half of the journey, slope is increasing and negative slope is increasing. Why should the slope be negative? Your velocity is in the downward direction. So slope should be negative. If you draw a tangent anywhere, here slope is 0. I am happy. If you draw a tangent at any point, slope is negative. Should be negative.
Yes, sir. Velocity is
Should be negative. I have 2 types of parabola. Firstly, displacement time graph should be a parabola. No doubt in it.
Yes, sir.
Because acceleration does exist. S is equal to half gt square. Y is equal to some constant into t square. So either this is the parabola or this is the parabola. Agree
Yes,
with
sir.
me? Now this cannot be a parabola because if I take this, here slope is decreasing.
Slope is
At
decreasing.
the lowermost point, slope became 0. Velocity doesn't become 0 at 2 seconds. Velocity
sir.
will be high. So this will be the slope. First part, is it clear to all?
Yes, sir.
Second part, again, this should be a parabola, either this or this. If I take this, slope is increasing. In the second part, slope should be decreasing because finally velocity is 0. See, velocity is 0, slope is 0. You have 2 options, either this parabola or this parabola. This parabola slope will become 0 at the topmost point. And I need
Yes,
that. This parabola slope will be increasing. No, for me, velocity becomes 0 at 4 seconds. Displacement time graph, all of you look at it carefully. Can I rub the board?
Yes, sir.
Yes, sir.
Yes, sir.
Now listen. Suppose I were to travel a distance of d. A train were to travel a distance of d. Now generally whenever they are using this train A and B, whenever they are using this train, please see the language carefully in the question. The train should stop at the station B. It starts from A and it stops at B. Right? Generally, how does a train travel? First, it will accelerate, then move at uniform velocity, and it will decelerate at T. It accelerated, it moved with uniform velocity, and then it decelerated. I take this to be T1, I take this to be T2, I take this to be capital T. Acceleration is alpha, deceleration is beta. The maximum velocity is B naught. Till here, is it clear? Alpha is the acceleration, beta is the deceleration.
Yes, sir.
So generally in the problems when they tell you a train goes from station A to station B, obviously they mean that train will come to rest at station B. It doesn't fly past station B. Right?
Yes, sir.
Now what will be the total distance traveled? Area of this half into V naught into T1 plus area of this V naught into T2 minus T1. Area of this half into V naught into T minus T2. Sum total should be equal to D. Area of this
Yes,
triangle, area of this rectangle, area of this triangle should be equal to the total distance. This is a velocity time graph.
yes, sir.
Yes, sir. Yes, sir.
Now listen carefully. Suppose I want to reach the other station in the shortest time interval. Suppose I want to reach the other station in the shortest time interval. I'll have to stop the train at station B, not fly past. Then what best can I do here? I'll remove this part. I will
Yes, sir.
continuously keep accelerating, but I will accelerate only to such an extent such that
At the
from
train
there
stop.
when I
can
decelerate,
decelerate back.
Accelerate and
Sir,
from
stop
the
at
there when
train
I
will
station.
stop.
decelerate, यार बोलने तो दो ना यार, बाकी बच्चों को समझ में आना है. I will accelerate to such an extent that from there I decelerate, I should come to rest here. I cannot keep accelerating till the station B. I will have to accelerate till such an extent such that from there they decelerate, I should come to station B. How will your velocity time graph look like? I remove
Yes, sir.
the
Yes.
state
Yes, sir.
of moving with uniform velocity. This point, is it clear to all?
Yes, sir.
Yes, sir.
This is V maximum. This is alpha. This is beta. right?
Yes.
The total time will be T. I'll call this T naught. Firstly, this is the situation for minimum time to reach B. First question asked is find V maximum. Second question asked is find the least time. Find T, that is the least time. Take this down and try for both the expressions. I'll solve them. Can I wrap the upper part of the board so that I can
Yes,
solve
sir.
the problem?
So 1 minute.
Can you wait?
First, we'll find out T naught. We can use cosine rule, sine rule, anything can be used, not an issue. 1 second, listen. What questions will they ask will depend on what variables the paper setter decides. What is alpha equal? V maximum minus 0 divided by T naught. V maximum minus 0 divided by T naught is alpha. So from here I will write V maximum is equal to alpha into T naught. If the paper setter gives you T naught, generally he will not give you T naught. T naught is something that you'll have to calculate. Similarly, how do I calculate beta? Beta will be 0 minus V maximum by T minus T naught. Final velocity is 0. Initial velocity is V maximum. So technically V maximum will be in this case beta into T minus T naught. I put a mod. Beta is negative. So I just put a mod. I'm telling you the magnitude of that. Beta will be negative. Obviously beta will be negative. Or remove the mod here and put it to the right. I'm okay with that. Fine.
Yes.
Now
Yes.
we are interested to calculate.
Yes.
Now V maximum in both the cases should be the same. Alpha T naught is equal to beta T minus T naught. Right? beta t minus beta t naught, right? Alpha t naught plus beta t naught. I take this to the left. My requirement was t naught. Beta t by alpha plus beta is the value of t naught. Generally, they will not give you the value of t naught. Now, in this particular case, don't substitute the negative sign for beta. I took the positive value of betas. Just magnitude you will substitute here to get the value of t naught. Right? So, firstly, if he is asking you for V maximum, this is the value. After finding out T naught, substitute either here or here, I will get T maximum.
Sir, why can't we take T naught to be half of total time?
How do we know that? Alpha and beta should be equal for that. T naught will be half only if alpha equal to beta.
Okay, sir.
If the rate of change of velocity in acceleration and deceleration are equal, then this will come at the center. If not, this will not be at the center.
Okay, sir.
Now listen. I know the total distance between the two stations is d. Half into V maximum into total time. Do you agree with this? Distance between the two stations is d. That means the area of this triangle should be d.
Yes.
You calculated V maximum from this. I'll rub this part. You calculate V maximum from this. Now that you know T naught, I will calculate V maximum. Are you able to see this part of the board?
Yes, sir.
Yes, alpha sir, into T naught, beta T divided by alpha plus beta. T naught I substituted here, alpha into this value. So half into V maximum is alpha beta T by alpha plus beta. It will become T square. So what is the total time of travel? Total time of travel 2d alpha plus beta by alpha beta with a square root will be total time of travel if my simplification is correct. So the
Sir, I did not understand this part.
The paper setter can ask you V maximum. He can ask you for T naught. V maximum, I have two ways of calculating. If T naught is not given, this is the formula for V maximum. And the distance between the two stations is given as D. He will ask for minimum time in which you can reach the two stations. How do you do that? Area of this triangle. Half V maximum, that is the height, into the base. Substituting the V maximum from here, I get the time. This time is the minimum time a train can take to reach the other station. Is this clear?
Why we can't take beta is negative?
Sir, should we remember this?
You have taken the positive value of it. If you take negative, then again put a negative sign in front of it. You are taking the magnitude.
Okay, okay.
Sir, should we remember this?
Not very essential. You can find out the area under this and finish up the problem. One second, just stay online. 1 second, just stay online. See, this is not a standard result, but the problem has been quite famous since long.
Sir, I didn't understand how did we get Vmax as alpha beta time upon alpha plus beta?
This T naught I substituted.
Okay, sir.
This T naught you substitute here, you will get Vmax.
So beta is the deceleration, so actually taking a mod.
You are calculating the area here, right? You
Okay,
will
for
not carry
the
a negative sign.
distance, yeah.
You will not carry a negative sign.
Yes, sir.
If I put beta negative here, I'll get the area to be negative, which will be
Yes,
wrong.
that's wrong, yeah.
So basic concept which I want you people to grasp here is when you want the least time to travel from A to B, the uniform velocity part is removed.
Yes.
Yes, sir.
So for least time, shouldn't alpha be equal to beta?
No. For a particular value of an alpha and beta, you are asking me the least time.
Okay, sir. Got
You
it.
apply again a condition for alpha and beta, that's a different issue. Now I'll differentiate t with respect to either alpha or beta and equate it to z.
Yeah, okay. So completed.
Yes, sir. Done.
So just sir.
Is it over?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
First 4 problems. Your booklet, exercise 3, comprehension 1. If you people feel the screen is not clear because of the small font, use your booklet. Exercise 3, comprehension 1. If I zoom in, 4th question will not be visible.
Sir, you don't zoom in. We can zoom in.
You can zoom in. Okay, perfect.
Sir, what is the page number?
Page number 158. Page number 158. I'll keep you people on mute. No, don't type the answers. I'll discuss it in 1 or 2 minutes. Can I stop the screen share?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
No. The first thing that they have given is a parabola displacement time graph is given. And they want the velocity time graph. Velocity time graph. This is displacement time graph means acceleration is deceleration here because the slope is decreasing. Here
Yes, sir.
slope became zero. Here slope is zero, implies velocity is zero. So first part is
Yes, sir.
decelerating,
Yes, sir.
right?
Yes, sir.
Second part, look at this. The slope is increasing.
Yes, sir.
Second part, slope is increasing.
The
But
velocity is
negative
also-
slope is increasing,
Yes,
right?
sir.
Second part, slope is increasing. Here slope is zero. Here slope is a finite part.
Yes.
But slope is negative all through.
Yes, sir.
Yes, sir.
Slope is negative all through. So velocity will come in the lower quadrant. Agreed?
Yes, sir.
Yes.
Yes.
Yes, sir.
Come to AT graph. All throughout it's a straight line. Acceleration A naught will be negative.
Yes, sir.
It will be AT graph. Right? Now, this is displacement. Make it distance time graph. Displacement and distance will be the same when they're traveling in the same direction. This
Yes, sir.
will
Yes,
become
Flipped it
positive.
upside.
This will not decrease. Speed will be increasing. You are able to see speed is increasing. Only negative sign of this is decrease. Right? So this will go in the upward direction. This point, did all of you get this clear? This is distance.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
The last was speed time graph. Speed time graph. Speed time graph. Distance and speed are scalars. You will not have negative values, so you kept it positive. And
So can you-
slope of this should be positive because that will give me speed. Slope of this should be positive. From here, have a look at it. Displacement became zero. This is about a particle going up and coming down. Displacement becomes zero, but distance is increasing. So distance increased. You cannot make it zero. It's increasing. So either this should be the graph or this should be the graph. This cannot be the graph because slope becomes zero here. Slope becomes zero implies speed becomes zero. Speed is not zero.
Yes,
Speed
sir.
is not zero.
Yes, sir.
Sir, I have a doubt in the fourth one, sir. Why not the option A is correct?
Fourth one, option A. slope of the speed time graph is positive at the first place, in the first part. It's not positive, right? It is decelerating. If you take this, slope is positive, you are taking it increasing. Slope of speed is positive is wrong. It is decelerating.
Sir, could you explain the second AT graph?
So can you explain the VT graph again?
VT graph, first of all, or first I take AT graph. Uniform deceleration all throughout. Speed is decreasing. So uniform deceleration. This is it clear to all? Uniform deceleration. All throughout it is decelerating. Right?
Yes, sir. Okay, sir. Thank you.
So this is negative. Once I know this is negative, slope of this should be negative all throughout. Slope of this should be negative all throughout. This is decelerating. Slope will be negative. It's decelerating. See here, slope is negative. How do you get that? See this angle theta greater than 90.
Yes, yes.
So the slope of this line should be negative because slope of this gives me velocity. So I drew it in the quadrant below.
Yes, sir.
And uniform acceleration. So this straight line should give me the same deceleration all throughout.
Yes, sir. Okay.
So can you tell the question number again?
What question number do you need?
Sir, of
1, 2, 3,
question
4
from
exercise 3.
Comprehension 1 exercise 3.
रामायण हो गया बच्चा पूछ रहा है सीता कौन है
Oh, sir, I was
प्रॉब्लम हो
from
गया
the
प्रॉब्लम
teacher.
नंबर पूछ रहे हो एक्सरसाइज 3 कॉम्प्रहेंशन 1
Sir, I have a silly doubt, sir. So why can't the displacement time graph be a straight line? So a distance time graph, sorry.
distance time if it is a straight line slope of that will be velocity it should be constant
And
Oh,
sir,
yes.
S is equals to ut, sorry, ut plus half at square, and initial velocity is 0, so s equal to half at square, and
which of
in
them
that
don't
condition,
confuse in that way which of them a simple
okay.
statement why is distance time graph what did you ask not a straight line distance time graph is a straight line that means velocity will be constant velocity is not constant rather speed
Yes, sir.
will become constant speed will not be constant.
Okay, sir.
Now, are you able to see this comprehension too?
Yes.
Can you people zoom into it?
Yes, sir.
Yes, sir, we can.
Yeah, comprehension 2, exercise 3 from your booklet. You have the booklet, use it. If not, use the screen. You have 5 minutes to solve this.
So can you repeat the question number?
Comprehension 2, exercise 3.
The whole thing?
Comprehension 2, exercise 3 of the booklet.
Okay, sir.
सब करना है
नहीं बस फोटो देखते रहो मैं डिस्कस कर लूंगा 2 मिनट के
सर मैं उसको बोल रहा था मेरे को पता है क्या करना है
okay I think you meant he was asking question number 5 6 7 8 में कौन सा करना है सभी करना है
Sir,
Hmm.
sir, when the velocity time graph cuts the x-axis once between 4 and 6, what time do we have to assume?
You will have to calculate.
We can see the slope and assume that.
From the slope, you will have to calculate that point of intersection.
Sir, do we send the answers?
No, don't.
Okay, sir.
My screen, I don't have the chat. I'll not be able to see what you type. I've got this questions on my screen.
Okay, sir. Okay.
2 more minutes, I'll stop the screen share and I'll discuss.
Okay, sir.
Sir completed.
Yes,
Yes,
sir,
sir.
done.
Sir, please wait.
So can you?
Yes, sir, done.
Okay, 1 more minute. Okay, listen. Have a look at the graph. At the first place, you have something like this. This is velocity time graph, meters per second. What is the time here?
2.
2 seconds,
2
4
seconds.
4
seconds,
seconds,
6
6 and 8.
seconds, 8
8.
seconds. Now this is not 5. I drew it in such a way so that it appears to be 5 but not 5.
Yes, sir.
10 and minus 20 because this is minus 20 and this is 10. So first question me, that was fifth question, right? They will ask me particle is not at rest. Here particle is at rest, here particle is at rest, here particle is at rest. Velocity time graph, it's very straight. Here particle is at rest, 0. 5 seconds will come somewhere here. This is not 5, I'm telling you, 8 seconds it is at rest. So at 5 seconds it will not be at rest, answer will be B.
Yes,
Fifth
sir.
question, I assume nobody would have had a problem with.
No, sir.
Right? Now,
Yes,
sixth
sir, no
question.
problem.
Yes, sir, no problem.
Delta V by delta T, slope. You are
Slope.
asking me, rate of change of velocity of the particle is maximum at which point? See, here rate of change of velocity is 0. You tell
Yes.
me this slope and this slope, I will be able to do the comparison. How
Yes,
will you get this slope? It is 10 divided by 2. I am getting this slope as 5. What is this slope? Watch out for this.
50.
This height, I'll be able to tell you this particular angle, right? First of all, let me calculate this theta. By default, I'll be getting this theta. This height is 20 plus 10, 30 divided by the time. Time is 2.
by 2. Yes, sir.
15.
Yes, sir. 50.
Now this is 15. What is this slope?
10.
10.
10.
So
20 by
5,
10.
15,
Yes,
10. Which slope is maximum? 15.
15.
But I'm speaking about mod. Minus 15 will be lesser than 10.
Yes,
So
sir.
paper setters generally don't play such cheap tricks, but sometimes they'll catch. Right? This is minus 15, this is 10, this is plus 5. Which slope is minimum means technically minus 15 is minimum. But if I put a mod, 15 is maximum. Right? Now, seventh question. If the particle starts from x naught is minus 15, x naught is minus 15, somewhere here, in 2 seconds. So find out the time here. X naught minus 15, find out the time here. You are starting from here. From there in 2 seconds, you know the position, how to calculate that. Sorry, I took this to be position time graph. Wrong. Wait, this is velocity time graph. He is telling you particle starts from the position x naught is equal to 15. X naught is equal to 15. What will be the
Minus
Minus 15.
Yes, sir, minus.
minus 5.
minus 15? Okay, x naught is minus 15, right? So in 2 seconds, what is the acceleration?
5 meters per second square.
5 meter per second square. So s is equal to, what is the initial velocity?
0.
Plus
0.
half a t square. That means this is 5 into 2,
10 meters.
meters.
10
You
meters.
started from minus 15, you will be reaching a distance of 10 meters. So your coordinates will be minus 5
Minus 5.
meters.
Plus 10.
Minus.
Now the best part of it, 8th question and 9th is a very important question. Maximum displacement of the particle. Listen carefully. Maximum displacement is A1 plus A2 plus A2. A1 plus A2 plus A2. क्यों भाई साहब आपने ये दोनों क्यों नहीं लिया?
मैक्सिमम पूछा है
Maximum
वो दोनों सब्ट्रैक्ट करेंगे नहीं यार. Net displacement is this minus A4 plus A5. I'll call this A4, I'll call this A5. Net displacement is this. अगर maximum
Yes.
पूछ रहा हूँ तो ये निकाल दूँ.
Yes, sir.
Simple, right?
Yes, sir. Yes, sir. Yes, sir.
Now, one more important thing. Listen carefully. What are the options given? Now, using this slope, I have to find this coordinates. I will solve the problem without finding the coordinates. How will you do that? Observe this. A1 plus A2 कितना? 30.
Yes, sir.
Yes, sir.
If I add A3, the answer should be greater than 30.
Yes, sir.
Yes, sir.
Only one option.
Yes, sir.
Yes,
33.6.
Yes, sir.
You can solve without finding out the coordinate. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Smart, right?
Yes.
Yes, sir.
Yes,
Logic,
sir.
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 Sir, but what if they had given one more option?
about
Then you
missing.
have to solve. We are talking
It
about
is
this
the
case.
reality. You heard of the cat paradox. Till I open the gate or the door of the box, I don't know if the cat inside is alive or dead.
Yes, sir.
Right?
Yes, sir.
Yes.
So they didn't
Finger
give.
cat.
Enjoy the fact that they didn't give. The question is meant for that.
Okay, okay, sir.
Seeing your
Yes.
smartness there, we don't want you to calculate this particular point.
Sir.
The paper setter, if he
Yes,
wants you to calculate this point, then he will give you. But now you know how to calculate that point as well. How will I calculate? I know the slope, right? I know the y coordinate. Can I calculate the x coordinate? Because if
So we
this
can
B
use
I know this,
similarity also.
So similar triangles.
similar
एक
triangles,
second
you
है.
can
हाँ
use
sir.
tan theta. So many things are there at your disposal. But how do I solve it without
Smart.
solving? A1 plus A2 is 30. There's only one option grade. And none of these, even if you would have given, then I'm forced to calculate.
Yes, sir. Yes.
Now that I know A1 plus A2 plus A3 is 33.3, something is given, right? 33.3. Now add A4 plus A5 plus A4 plus A5 will be the 9%.
Yes, sir.
Yes sir.
10th is quite easy. Here acceleration is constant, here acceleration is 0, here acceleration is negative, here acceleration is positive.
Yes, sir.
So, but in the
Yes, sir,
options
and
they've given
everywhere
magnitude.
it will be constant.
In the options they have given magnitude.
Sir, I mean, in the graph they have given in the options. So it's positive, uniform, negative, then positive, but the magnitudes are different in all the options.
Yeah, of course.
Magnitudes are different. Yeah, slope is 5, yeah, slope is 15, yeah, slope is 10.
Sir, that only I'm saying.
सही तो दिया है. I'll have to rub the board to put up the 9th and 10th rather than 10th and 11th.
Sir, for the maximum displacement, we have to assume that the graph does not go below the x-axis.
We have to neglect that part.
That
Total
part,
displacement
for total displacement, that part will be subtracted from this. Agreed?
Yeah, yes.
Maximum displacement कौन सा होगा?
Yeah, only the positive. Okay.
Sir, could you explain the sixth question once?
Sixth
So the
question.
seventh one.
Slope.
Slope of this line. Slope of this line. Slope of this line. Magnitude, which is maximum. 5, 15 and 10 में which is maximum?
15.
So can you explain the seventh one once more? The significance of x naught in that.
X naught, the particle is traveling this way along x-axis. It is starting at minus 15. In 2 seconds, it has an acceleration of 5. So in 2 seconds, it will cover a distance of 10 meters. That means it is at minus 5 meters.
Oh, okay. Yes, sir.
Can I rub the board?
Yes sir.
Yes, sir.
Yes, sir.
सर सर
हाँ बोलो.
सर जो 9th क्वेश्चन है उसमें सॉल्व करके मेरे को 56.6 आ रहा है और ऑप्शन में 66.6.
हाँ वही है भाई 66.6 है.
66.6 ही आता है.
एडिशन सब्ट्रैक्शन ये सब एलकेजी में सिखाते हो भाई साहब, अब नहीं सिखाएंगे.
I have made some mistake. Okay, sir.
Till now I have taken time on the x-axis.
Yes.
Yes, sir.
Now you know what is next.
Time on the y-axis.
Displacement.
Displacement on that.
Oh wait, दो और क्वेश्चन से यहाँ है, forgot. भूल ही गया. 10th question में it's quite easy. Acceleration is 5 during the first 2 seconds. Here acceleration is 0 from 4 to 6 seconds. Acceleration is negative minus 15. Then it is positive
10. Yes.
10. ये तो values पता है हमें, we can directly do that. Displacement time graph. Have a look at this. Firstly, here it's uniform acceleration. Displacement time graph will be parabola and that too increasing slope.
Yes, sir.
Yes, sir.
Parabola with increasing slope. Here, velocity is constant, so displacement should be a straight line.
Yes, sir.
2 to
Yes,
4
sir.
may displacement should be a straight line. Now here it is decelerating, right? Decelerating till 6 seconds. Now again it is accelerating, but velocity becomes 0. Wait, it is accelerating. Yeah. Is that correct? Did I go wrong here?
No, sir.
ऐसा कोई option ही नहीं है. 4 to
सर
6
6 पे
it goes
नीचे आएगा
down.
थोड़ा. हाँ.
Yes,
Yes,
sir.
sir.
Yes, sir.
Velocity becomes 0 here. Yeah, velocity here is negative. From 6 to 8, velocity is negative. It is below the x-axis. So slope should be negative. Slope should be negative.
Negative and
Velocity
increasing.
graph and not. Slope should be negative because velocity is below the x-axis.
So over there, slope will be negative and decreasing.
Naturally.
Yeah, so approaching 0.
Approaching 0. So velocity becomes 0 at 8.
So before 6 only it will start decreasing, right?
Yes, sir.
सर 6 से पहले ही कम होना शुरू हो जाएगा ना?
6
तो 4 के बाद
यहाँ पे 14/3 पे आता है, वहीं पे
Yes,
कम
sir.
होना शुरू
Point
हो
after 4.
From 4, the body is decelerating. All throughout it is decelerating, right?
Sir, the point when it cuts the x-axis, from that it would start becoming negative, not from the 6.
Yes,
Yeah,
sir.
so
So it will be
4.67.
becoming
सर
negative a bit after
4.67
4.
से वो नीचे होना शुरू.
From here, velocity is negative. That's right. So
Yes, sir.
technically, this will be that value of something called 5 point something something, whatever you get.
It's 4.67.
4.67. Yes, sir.
4.67.
जो भी है. Now, the next stage is taking displacement on the x-axis. It will involve little bit of a calculus. The assignment that you will receive today, there are 1 or 2 problems in that with displacement on the x-axis. Not that it is impossible for you people who can try that. The others, displacement on the x-axis का जो 2 problem है, keep them pending for the next class. Is the instruction
So you can
clear?
try, sir.
Yes, sir.
Yes, sir.
People who can
Sir.
try,
Yes,
go
sir.
ahead. People for whom they need help, I have done only up to time on the x-axis. Solve only those problems which have got time on the x-axis. Is the instruction clear?
Yes.
Yes, sir.
Yes, sir.
You will receive the assignment by evening.
Okay, sir.
Okay, bye, sir. Thank you.
Bye, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Sir, thank you so much, sir.